All right, we're graphing in standard form. This is for all you virtual people. We're in first period. If you're a first period student, you're in your normal class here. So when we've been graphing always the y equals mx plus b. And what form is that called? Slope intercept form. Okay. Well, today we're going to graph from standard form. The only difference between slope intercept form and standard form is that the x's and the y's are now on the same side. So when we're dealing with this, we can graph the intercept. And so I want you to write this down for me. We're going to find the y-intercept and we're going to find the x-intercept. So when x is 0, I want you to cover up with your finger the x term. Because if x is 0, it's not even there, right? So negative 4 times what is 8? Not 2. Negative 2. All right, let's find that dot. 0 back and forth, 2 down. Is that my y-intercept or my x-intercept? That is a y-intercept. And we've talked about before that anytime we're touching on the y-axis, in order to touch there, I can't go back and forth any. So the x value of a y-intercept is always 0. The y value, the up and down of an x-axis, is always 0. So now we're going to do the same thing, except we're going to put a 0 in here for y. You can either cover that term with your finger, which is what I do. I just cover the entire y term and read the statement. What does it say? X equals 8. If that bothers you, though, and you feel like you didn't do enough work, then you can go ahead and put a 0 in for y and see that that becomes a 0, and we still have x equals 8. So Ms. Boykin just prefers to cover it because the 0 means it's not there, and save myself ink. Okay, so I like my blue pen. I don't want to waste all the ink. So here we go. 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. How many points does it take to draw a line? Looky there. We have a line. Over here on the side, you do not have to do this, but I want to show you something. I'm going to put this into slope-intercept form by moving the x term and then dividing by y's coefficient, just to prove to you that the y-intercept really is the same. And the slope, rise 1, run 4, rise 1, run 4, really is the same. So when we're graphing lines, it doesn't matter how you graph it. You can make a table, you can find the intercept, you can put it in slope-intercept form, you can find a point and follow the slope, but it should always be the same line. Oh, yeah. Do you mind? It's over there. I prefer, if it's in standard form, the easiest way to graph it is find the intercept, because it's very easy to plug in a 0 for x and then do the same thing, plug in a 0 for y. That's way easier than solving and moving things and plotting the intercept and finding the slope. So let's try it for this one. Thank you, Gracie. If x is 0, so algebraically this is what it looks like, but you don't have to do it like this if you don't want to. If x is 0, that makes that 0. 8y is negative 40. So what is y? 8 times what is negative 40? Negative 5. Now, if I was doing this problem by myself, I would never show all that. I would just say, okay, x is 0. When x is 0, I'm going to cover up my x's. 8 times what is negative 40? Oh, okay, negative 5. I'm going to do the same thing with the y term. When y is 0, what is x? 10 times what equals negative 40? Negative 4. Let's plot those 2 points. So this is my y-intercept because the x is 0 back and forth, and I go down 5. 1, 2, 3, 4, 5. I'm going to label x and y in case you're confused. And for the x-intercept, I'm going to go left 4 and up and down none because it's an intercept. It has to touch the x-axis. And there's my line. So if you prefer to write out all the algebra, you can. Or you can just write the 2 zeros in, cover, and fill. Why are you all fuzzy? There you go. Questions so far? This only works when it's in what form? Standard form. Okay, this little guy. When x is 0, what is y? When y is 0, what is x? We're looking for our intercept. So let's cover. If x is 0, beep, that whole thing has to be 0. So we have negative 6 times what equals 12? Negative 2. All right. Now we're going to do the same thing with the y value. If the y is 0, I'm going to cover the y term because that makes negative 6 times 0 is 0, right? So that's gone. So 4 times what is 12? Let's plot our dots and connect them and we'll have our line. So 0 back and forth, 2 down, 3 to the right, none up and down, and draw a line. How do you feel? Is this pretty easy? Okay. I'm going to give you like 3 minutes. I want you to try this one by yourself just to see if you're on the right track. Find your zeros and plot your line. Go. This is the line you should have. Yes. Whenever y is 0, watch this. 5 times what plus 3 times 0 is 15. Well, that becomes 0.
Okay, I see.
So now, so if you have to show the algebra, at least, for a day, do it. It's worth showing yourself why we're covering it. We're covering it because it becomes 0. Now, on number 7, as you get better and better at graphing these, you're going to change your strategy. This is in standard form, but how easy would this be to move the x to the other side and graph it the way we've been graphing? You don't have to divide anything. So I'm going to do it both ways with you. I'm not going to tell you one way and then not do it that way, but as you get better at this, that's going to be a lot faster for you to graph, to just move it over. So if x is 0, what's y? Okay. If y is 0, what's x? Because it says it. So 0 back and forth and 3 up. 3 to the right and none up and down. Now I just don't believe Miss Boykin, it can't be this easy. So I'm going to check out this line over here and see if it's the same thing. Y-intercept is 3. Y-intercept is 3. Slope is -1. That means down 1 over 1, down 1 over 1 all day long. So you're going to get to use your expertise. When you get to Algebra 2, your teacher's not going to say, you need to graph the line using this method or this method. You get to pick what is easy for you. Do you always want to put it like this? Do you want to graph the zeros? Do you like finding the point in the slope? It's going to be up to you guys. All right. This one is going to get a little different. 0, 0. So let's look and see first. I'm going to do this for you, Gracie. Let's look and see first if x is 0. That gets rid of our x term. What is y? -3 times what is 15? -5. Okay, now we're going to do the same thing. And we're going to put a 0 in for y, which makes that whole term gone. So 10x equals 15. Is that an easy number? No, but can we do it? Absolutely. What is 15 over 10 reduced? So let's think about that. That's 3 times 5 on the top and 3 times 5 on the top and 2 times 5 on the bottom. And anytime you have something in the numerator and denominator, it becomes a 1, because 5 divided by 5 is 1. That's how we reduce fractions. So you're right, this is 3/2. That's ugly, but we can still do it. Is 3/2 like that? How big is that as a decimal? 1.5. So on the x-axis, we go over 1.5 and put a dot. And on the y-axis, we go back and forth 9 and down 5, put a dot. Then we draw a line. Not as pretty as the other ones, but still okay. Okay, we only have 2 graphs left. So I'd really like you guys to try. Both of these are going to have a decimal. So it's not going to be nice and easy as the first couple, but you can do it.